So we're given these enthalpies here. So we have standard enthalpy of this, or let me write delta H here. So delta H of ng is going to equal 472.7 kilojoules per mole. I have delta H of Hg is going to equal, this is 216.0 kilojoules per mole. And then finally I have nh3. This is going to equal negative 46, sorry. 0.1 kilojoules per mole. So given the standard enthalpy of these guys here, we want to find the N bond H bond energy here. Nitrogen single bond into this hydrogen in ammonia here. So what they're doing here is they're actually going to write out the balanced chemical equation, which is great. So we can do that here. And so we have N2 plus H2 will give us NH3. So we're going to have to add a 2 here. To balance out that, and then we're going to have to add a 3 here to balance out that as well. So again, I have 2 nitrogens here, 6 hydrogens on this side, 2 nitrogens here, and 6 hydrogens on this side here. And what they're doing here is they're writing, what we can do to this equation here is you can actually divide everything by half, right? Because again, this is here for 2, this is for 2 ammonias, and this standard enthalpy is only for 1. So I can divide everything here by all the coefficients here by 2, right? So I'm going to have half NH2 plus 3 over 2H2 would give us 1 NH3. And we care about 1 NH3 because this is going to give us negative 46.1 kilojoules. So that's what they have in this first, in this kind of first step here. And we're given all of these guys here, right? We're given our N2, which is our N2 here is simply, this should be N2. I don't know why they have N here. But this is going to be half of 472.7 because again, the coefficient of half. So I'm going to have to multiply this by half. And or if this actually gives us N, then I don't know if it's actually N2 here. So I'm going to give them the benefit of the doubt and say that this here is N and not N2. So in this case here, I don't have to actually multiply by half because this is just only for 1 nitrogen, and we only have 1 nitrogen here. So I'm going to say that we're going to have, this is going to be our number for our equation here. So again, as you can see, N here is half of N2. So it's going to be negative 472 kilojoules per mole. And again, this here is going to be an exothermic reaction. So we're going to have to change the sign here to a negative. And then what we have here is we have H, so we're going to have to multiply this by 3 over 2. Or we're going to have to multiply this by 3, right? Because the 2's here cancel out, so we're left with 3 hydrogens. So we're going to have to multiply this guy here by 3 and flip the sign. And we're going to have to add all that up. So we're going to have this here would be negative 472.7 kilojoules per mole. Plus, and then I'm going to have multiplied this guy by 3 and flip the sign. So I have 3 times negative 216.0 kilojoules per mole. And then what we're going to have here is, and also have to add in the ammonia, obviously, which is negative 46.1 plus negative 46.1 kilojoules per mole. So this is going to equal, we're going to add up all the reactions together. So this is great. So what we have here is half NH2 plus 3 over 2 H2 N and 3 H's, sorry. It's going to yield ammonia half and 3 over 2. So what we're left here is we're left with nitrogen and our 3 hydrogens and our ammonia here, which is exactly what we have here. So we simply just have to add up our enthalpies here. So simply like so, and we will get our solution here. So this is, so mathematically this is negative 472.7 minus, this would be 648 minus 46.1. And this will give us our enthalpy, or this will give us our delta H of our entire reaction. So this is 648 minus 46.1. This is giving us negative 1,166.8 kilojoules per mole. And this here is the delta H of this entire reaction, right? So for NH3, because remember this here was our reaction in the beginning. So we have NH3, and we want to figure out each bond energy with NH3, right? So again, with NH3, if you drew the Lewis structure, we recognize that NH3 has 3 NH bonds. And because this here is for the entire reaction of NH3, we actually have to divide this guy here by 3 to figure out the individual bond energy of one NH bond here. So I have the answer divided by 3, which is going to be negative 388.9, exactly what their solution here as well. This should be a negative here, 8.9 kilojoules per mole. So this solution is indeed correct. Good analysis.